So, I hope you all have had a really fun day thus far, learning all kinds of stuff from us scientists. So I'm between the worlds of grad student and professor at the minute, looking for a job. But really, who am I, and where is my journey? Why should you believe anything I'm about to say? Well, so I began my journey in this country. So can anyone tell me what this country is? It's a country called Northern Ireland. It's not all. Technically, the country is Britain. It's Northern Ireland. And I lived in a remarkable place because within 20 minutes drive, I could be in the ocean, I could be in a mountain, I could be in a forest, I could be in some beautiful natural world with beauty like this. And throughout my entire childhood, I was constantly, impressed by this and wondering how much we can understand it. And so, for example, in this picture, you can see the cliffs. The cliffs are millions of years old. You can see the castle. The castle is hundreds of years old. But the thing they share is they all tell a story of some past world. The cliffs were laid down in some ancient epoch. The castle was laid down where humans still rode horses everywhere and stuff like this. And so I started to become interested in how we can piece together the puzzles, the history of Earth, of life on Earth, and everything connected to that. Therefore, I was lucky to be able to come to America and study science and explore various parts of the country and the world. So I got to climb trees, as Sarah said in your introduction, in Hawaii on the top right. I got to climb mountains in California on the bottom right. And I got to go to the Grand Canyon and look very, very close at rocks, like at the top left. Geologists are look really close to rocks just to see something. But it is at the Grand Canyon that our journey begins. Because I would very much advise all of you to visit the Grand Canyon if you can at some point. This is a picture of it. And I'm going to tell you about lesser known worlds, wonders in the history of life. And why does the Grand Canyon matter for this? Well, the most interesting thing about the Grand Canyon, other than its size and majesty and all this stuff, is that it's got all these layers. So you can probably see the layers from where you are. These layers are laid down over millions of years as things like sand and sediment and things on the Earth are laid down and compressed into rock. And millions of years after millions of years pass and lay down more and more layers. And so you can think of each of these layers on the Earth as being pages of a book, a stack of books that the Earth has laid down throughout its history. And in each layer, there is another story, there's another past, another castle was built, another cliff was laid down. And scientists can peer down through this book of life and learn what the history was of life that used to live on the Earth. So I said lesser known wonders. Hopefully you will see why the talk is called lesser known wonders and not greater known wonders. But let's dig back relatively recent times. Let's dig back 10,000 years. And people start digging up bones like this. This is a woolly mammoth. It's lost its wool. It's mostly just bone. But these creatures lived about 20,000 years ago during what's called the Ice Age. And it used to be that we would dig these bones up and people would think, oh, this is just a weird sort of elephant that lives off in a weird part of the world. We just haven't found it yet. But it wasn't until Cuvier in 1798 started comparing the bones of this mammoth that we now know it as to modern day elephants, which are what it kind of looks like, and said, no, this is too different to anything that lives around today. We can tell what from the bones. This must be a species that used to exist on Earth, but now has gone extinct. And for the very first time in human history, this idea that animals could go extinct over time brought into science, relatively recently, only about 1800 or so. So we know that there were these incredible creatures that used to live on the planet that are now lost to us, hidden away in the layers of the Earth. However, I want to talk to you about lesser known wonders. You've probably most of you seen a mammoth before, partly because they made a movie out of things such as mammoths. And the theme of this talk is, if it was popular enough to make a movie out of, we don't really care about it. So we're going to dig a little bit deeper. So we're at 20,000 years. Let's dig, 150 million years ago. So you probably all know about dinosaurs. So everyone goes crazy about dinosaurs. And dinosaurs were first named in 1824. They've been known for a couple of centuries. And they're famous references. They were these big, scary, crazy reptiles like T-Rex and all this that you probably know and love. But they got a movie, so we're just going to leave the dinosaurs as this interesting thing and see what existed before the dinosaurs. So the dinosaurs lived about 200 million years ago or so. We're going to go back to a period just before them, the so-called Triassic period. And this was about 220 million years ago. And had I not already told you that we were going before the dinosaurs, you may look at this picture and think this was a dinosaur. This big, scary thing with like teeth and all this stuff. But the dinosaur in this picture is actually the thing in the jaws of the beast. The beastie is actually more closely related to things like crocodiles. So the world before dinosaurs had things that were just as big and scary as dinosaurs, actually bigger and scarier, but they were more closely related to things we know today, i.e. crocodiles. But there are actually 500 million years of life, of big life on the Earth. We're only going back about 220 million years, so we're going to need to speed up if we're going to get back into the real depths of time and history. So let's go a little bit further back, before the Triassic. And also the world looks a little bit different. It's got reinforced, covered in reinforced. This is the Carboniferous period, 300 or so million years ago. And you might walk around the Carboniferous here, and it kind of looks like a rainforest today, but you feel very energetic for some reason. It turns out the reason why it's you feel very energetic is because there was about twice as much oxygen in the air, 50% more oxygen in the air during the Carboniferous period than today, because of all these trees pumping out oxygen. So you probably know trees are known as the lungs of the planet because they pump out all this oxygen. Well, the planet covered in trees produces a lot of oxygen, so you might be kind of happy. However, other animals like oxygen as well, such as bugs. And I put a dragonfly and millipede in this picture that are the size of dragonfly and millipede are today. But during the Carboniferous period, because of all this oxygen, these things like to grow big. They have enough oxygen to grow big. And in fact, this would be the actual size of a dragonfly and millipede back during this time. So dragonflies are about 2.5 feet across. Millipedes could look some of you in the eye. So your extra oxygen-fueled happiness may quickly turn to anxiety, and you may wish to dive further back into the planet's history and see, okay, can we find a time when there's something that's not going to scare the big daylights out of me? So, you go back a little further. Let's go back another 100 million years. Back to the so-called Devonian. And the Devonian period, most of the life that you would be interested in is under the ocean. So we've dived under the ocean. And just like today, there are lots of fish around in the ocean. But the weird thing about the fish during this ancient time period is that they had a lot of armor. They were swimming around, and you could, hit them with a hammer, and they wouldn't feel it because they're covered in armor. It's a very different type of fish that's around today. However, the fact that they have a whole bunch of armor is hinting that there's something scary in the water. There's something. We've seen dinosaurs, we've seen giant crocodiles, but turns out these fish were not armored just for fun. They were armored because they were hiding from this thing, Dunkleosteus, my favorite fish ever to live, an absolute unit of fish. And this is its skull. So, well, first of all, we have a diver scale up there. It was 30 feet long, and it was also armored. But the skull that we have here, it looks like this monster had teeth, but this monster did not have teeth. Dunkleosteus is too cool for teeth. Its skull, the bones of its skull, have grown into the shape of a plant, such that it can make short work of all those armored creatures that are swimming around in the ocean. So, if you're swimming around in the Devonian period, you might listen to the words of the famous Jedi, Qui-Gon Jinn, there's always a bigger fish. He said that in one of the movies. Qui-Gon Jinn, also from Northern Ireland. Well, not Qui-Gon Jinn, the actor that plays Qui-Gon Jinn from Northern Ireland. Qui-Gon Jinn, I don't know what planet is Qui-Gon Jinn. Anyway, so we've still got some time to go back. We were only back 400 million years. Let's go back to the very beginning of when there was life that was big enough for you to see with the naked eye. And this is the so-called Cambrian period. So we're right at the bottom of this stack of books of life. And again, most life is under the ocean. There aren't any fish. There aren't any fish yet. Fish have not evolved. It was all kind of seashells and things that look like this. And this is the first time we see in the fossil record these layers on Earth that there was life that you could see with the naked eye. But that doesn't mean life didn't exist before then. Life actually, we're at 540 million years, life went back to 3 billion years. It went back 6 times as far. But we don't have much of a record of it in the rocks because it didn't have shells and bones and things like that. So this sudden origin of fossils of 540 million years ago, I liken to the sudden origin of what we see from human history, of whenever humans started writing on walls and leaving cave paintings and things. Humans have been around for a long time, but only once we start leaving our mark on the earth do we start seeing evidence of our history in the rocks. And just like that, life suddenly started showing evidence of its existence about 540 million years ago, but it actually was around much, much longer than that. So, we could, as I say, we could go back millions and millions of years more, but let's go back to today, because we started at the top of the stack of books, which is today, and we dug our way down to the bottom. But we must find all these wonderful features along the way. But we can't forget that the world we live in today is also infinitely beautiful. It has so many interesting mysteries to learn and stories to tell that we are still only starting to uncover. Of course, it's got life as well. So, in addition to all these stories that the world has today, for every layer that you go back in Earth's history, for every page of the Book of Life, there's another amazing world with all its mysteries and everything. So you can think of there being thousands of alien worlds beneath your feet. But, as Sarah said in her introduction, mostly I study planets around other stars. And so it turns out that most stars in the sky have other planets around them. And so not only are there these thousands of alien worlds beneath our feet, there are thousands of alien worlds above your head as well, circling the stars in the night sky. So there is an infinite number of worlds to explore. And so I'm going to finish with a quote from one of my heroes and a famous BBC presenter of nature, David Attenborough. He said, "I just wish the world was twice as big and half of it was still unexplored." Meaning there's this idea that somehow we've learned everything about the Earth that there is to learn and it's getting boring. But in a sense, that's not true, because first of all, there's a lot we still need to learn about the Earth today, but for every foot you dig down in the Earth, there's another loads of stories to unfold and so much up in the air that hopefully I've convinced you that there's going to be mysteries and intrigue to fuel a scientist for years to come. And hopefully some of you will lead that charge. So I hope you enjoy the rest of the talks. Thank you.
Yeah, does anybody have any questions for Chris? You can take a few questions. Yeah.
Why did you go back to single-cell organisms?
I didn't go back to single-celled organisms because, first of all, the fossils that we have of them aren't particularly interesting, and I wanted to focus on things that were big and scary, essentially, and unfortunately, single-celled organisms are very big and scary, unless you're another single-celled organism. If you look at if you blow up single-celled organisms and look at how they interact, you can see that they kind of chase each other around and eat each other, kind of like a T-Rex would chase around a person and eat a person. So, you know, if I did give another talk starting 500 million years ago and then look at all the crazy things that play out at a small scale, it would still be interesting, but you can't cover it all in one go, unfortunately. Yeah. That's a very good question. So, can we survive back in time in the Earth? We can survive back to about 500 million years. So, what we need to survive is oxygen. We need to be able to breathe oxygen. As I said, back in the Carboniferous, there was actually more oxygen than today, so you're fine, at least for a short time scale. But once you get to 400 or 500 million years ago, the oxygen of the Earth was actually very, very low. It was only about 1% of what it is today. And so, back further than 500 million years ago, you wouldn't have enough oxygen to live off of. And it's the reason for why oxygen grows is actually not entirely known, but it's thought to be one reason why you suddenly get to see big creatures. Because all of a sudden there's enough oxygen to support big creatures.
Okay, one more question.
Is a mammoth bigger than an elephant? Depends on the mammoth. Mammoths got bigger than elephants. This is probably because it was colder. So if you're colder, it turns out if it's colder climate, animals tend to get bigger, because if you're bigger, you can conserve heat better. So mammoths, in addition to their wool, were big to conserve heat during the Ice Age.
Okay. We have a very, very enthusiastic question right here in the gray shirts. We'll take this one as our last one.
Different kinds of elephants.
Sorry?
He's asking different kinds of elephants.
Oh, there's actually a species of pygmy elephant that lives on an island, and it grew really small for some reason. It grew about the size adult. So there are different sizes of elephants, some of them not very small. So you could ride that.
Okay, let's thank Chris.